I was actually really bad at chemistry in school, so this video is my feeble attempt at redemption. In chemistry, the pH scale is a scale used to specify the acidity or basicity of an aqueous solution. Søren Sørensen, a Danish chemist, introduced the concept of pH in 1909. This scale was developed as a means to express the hydrogen-ion ratio on a logarithmic scale, which he called the pH scale. The letters pH are an abbreviation for pondus hydrogeny, meaning potential hydrogen. Any water-based liquid can be classified as an acid or base. Water is neutral and has a pH of 7. Acids have a pH less than 7, while bases have a pH higher than 7. Oils and other non-aqueous liquids are not acids or bases. It would be good to note that each time you move a number, it is increased or decreased in potency by 10. So pH of 6 is 10 times more acidic than a pH of 7, and a pH of 4 is 100 times more acidic than a pH 6. There are different definitions of acids and bases, but acids can accept an electron pair or donate a hydrogen ion or a proton in a chemical reaction, while bases can donate an electron pair or accept hydrogen or a proton. Acids and bases are characterized as strong or weak. A strong acid or strong base completely dissociates its ions in water. If the compound does not completely dissociate, it's a weak acid or base. How corrosive an acid or base is did not actually relate to its strength. Acids and bases react with each other in what is called a neutralization reaction. The reaction produces salt and water and leaves the solution closer to a neutral pH than before. One common test of whether an unknown is an acid or base is to wet litmus paper with it. Litmus paper is a paper treated with an extract from a certain lichen that changes color according to pH. Acids turn litmus paper red, while bases turn litmus paper blue. A neutral chemical won't change the paper's color whatsoever. Because they separate ions into water, both acids and bases conduct electricity. Since both acids and bases can be corrosive, you can get chemical burns from either one. Acids tend to taste sour and feel drying or astringent, while bases taste bitter and feel slippery or soapy. Acids and bases are important to the human body. For example, the stomach secretes hydrochloric acid to digest food. Meanwhile, the pancreas secretes a fluid in the base bicarbonate to neutralize the stomach acid before it reaches the small intestine. Here's a list of some pH values of very common foods. You better commit this entire list to memory. Quick note, since a lot of the pH levels vary depending on a lot of growth factors or specific species of food itself, I will be giving a little bit of a range for the pH value. First up is apples, which have a pH value of 3.3 to 4. Apricots range from 3.3 to 4.8. Artichokes from 5.5 to 6. Asparagus range from 6 to 6.7. Avocados range from 6.27 to 6.58. Bamboo shoots are from 5.1 to 6.2. Bananas range from 4.5 to 5.2. Beans range from 5.6 to 6.5. Beets are 5.3 to 6.6. Broccoli is 6.3 to 6.85. Brussels sprouts are 6 to 6.3. Butter is 6.1 to 6.4. Cabbage is at 5.2 to 6.8, a bit more of a range there. Cactus actually sits in at 4.7. Meanwhile, cantaloupe is at 6.13 to 6.58, and carrots are from 5.88 to 6.4. Cauliflower is actually at 5.6, and celery is about 5.7 to 6. Cherries are pretty acidic at 3.8 to 4.54. Chocolate milk is actually 6.5 to 7.5, so is regular milk for the record. Corn is sitting at 5.9 to 7.5, can be pretty sweet. Cucumbers are at 5.12 to 5.78, while dill pickles are at 3.2 to 3.7. That vinegar really brings in the acidity. Grapes are actually 2.8 to 3.8. Can you believe they're more acidic than actual pickles? Horseradish hovers at about 5.35. While ketchup is pretty acidic as well at 3.89 to 3.92. Lemons are 2 to 2.6 and limes are 2 to 2.8. Maple syrup is about 5.15 and mushrooms are about 6 to 6.7. Mustard hovers anywhere between 3.6 to 4, and the ocean is actually about 8.1. Onions are between 5.3 and 5.88. Oranges are 3.69 to 4.19. We got parsnips at about 5.3 to 5.7. We got nectarines at 3.3 to 4.05. Peanut butter is around 6.3. Pineapples are 3.2 to 4. Potatoes are actually at 5.4 to 5.9. A bit more acidic than I would have thought. Pumpkins are 4.99 to 5.5. Raspberries are 3.22 to 3.95. We got strawberries at 3 to 3.9. Tomatoes 4.3 to 4.9. Vinegar at 2.4 to 3.4. Watermelon at 5.18 to 5.6. And of course, to wrap things up, we got zucchini, the mighty Zuck, at a pH level of about 5.69 to 6.1. Zuck himself is actually at a pH level of about 7.35 to 7.45, seeing as both human bodies and lizards range in that area. Wow, what a great video. The moral of this story is don't drink bleach. I don't know, you'd think at this point I'd plan these things out better. Anyway, thanks for watching. I hope you learned something about pH values and that you'll go around spouting off the values of random things around your house. Take care, everyone, and as always, don't be a dumb fork, be a smart spoon.